Hello, Algebra 1. Today's video we're going to continue on factoring, but today's lesson is going to deal with factoring a trinomial out of standard form, similar to what we did the last time, except this time a is not going to equal 1. If you remember, all of our equations that we factored in the last lesson had a leading coefficient a that was equal to 1. So all of our equations that we're going to factor this time, a is going to be greater than 1. And those steps that we worked last time, where we just did the diamond problems, we figured out what factor pairs of C we multiply, well, what factors when we multiply them together equal C, then when we add together equal B. Okay? That will not work if A is greater than 1. So there's just a couple more steps we need to take in order to factor a quadratic expression like this one here when A is not 1. So here are the steps. Step 1, we're going to find the factor pairs of A times C. So we're going to be looking at A times C. We're going to multiply those two coefficients. That's why this method is often called the AC method. But step 1, we're going to find the factor pairs of A times C that when added together equal B. We're going to rewrite our equation. We're going to change our middle term using those two numbers that we found in step 1. And then we're going to group that rewritten equation. We're going to find the GCF of our groups and then rewrite. Okay. Right now, when you just read those steps for the first time, it's very confusing, and that's okay. But let's go through a few examples, and hopefully that'll clear it up. So let's look. Our first example will be 4x squared plus 21x plus 20, and that'll equal 0. Okay, so you see right here, we have our A is greater than 1. So we know that that diamond method problem that we used last time is not going to work. So we have to look at this method. So we are going to find the factor pairs of A times C. Well, A is right here, 4, and 20 is right there. Or I'm sorry, C is right there, 20. So A times C is going to equal 4 times 20, which equals 80. Okay. Now we have to find our factor pairs of 80. So what are those? Well, we have 1 and 80. But when we add those together, that equals 81. We're looking for 21. We want it to equal B. Next would be 2 and 40. We add that together, that's 42. We're still not there. 3 doesn't go into 80, but 4 does. And how often does 4 go into it? It goes in 20 times, so we're still not quite there yet. And then we'll have 5. How many times does 5 go into that? 5 goes in 16 times, and there we go. Okay, 16 times 5 equals 80. So that's going to be our pair right there, because when we add 5 and 16 together, we do get 21. So let's just write that off to the side over here. 5 and 16. Those are our numbers. And we're going to move on to step 2. Okay, step 2 is write the equation changing the middle term. And we're going to change the middle term using these two numbers right here. So our lead is still going to be 4x squared, but we're going to split 21x into plus 5x and plus 16x, and then the 20 stays the same, equals 0. Okay, so we didn't really change anything. We just found these two numbers a way to split it. So because 5 plus 16x, that is still 21x. But the reason why we rewrite it now is we are going to group this. We're going to look at the first two terms in our equation and the last two terms in our equation, and we're going to figure out the greatest common factor of these two terms. Okay, greatest common factor was, I think it was 2 or 3 lessons ago, so hopefully we have that down. What is the greatest common factor of 4x squared and 5x? Looks like it's just going to be x. We don't have a factor that goes into 4 and 5, but with x we do. X goes into x squared, and of course x goes into x. So if we take x just out of that term, we'll end up with 4x there and plus 5. Okay, x times, so if we were to distribute that x back through there, we would get 4x squared plus 5x. Now we're going to take a look at our second term. What is our common factor here in 16x? Well, we don't have another variable term, so that's going to stay the same. But what about our numbers? What's the greatest common factor that goes into both 16 and 20? And that would be 4. If we pull 4 out of this expression, 4 goes into 16x 4x times, and then 4 goes into 20 5 times. So if we've done this correctly, if we've figured our greatest common factor correctly out of our first two, this first group and our second group, the term inside the parentheses is going to match. Okay, it has to match. If these two don't match, you've done something wrong and you need to go back up here and fix whatever that may be. Well, what's nice is if they do match, you remember when we were factoring before, earlier, we had two sets of parentheses, correct? So our second set of parentheses will be that set that matches right there. What goes in our first set of parentheses? It's these two terms right here, x plus 4. This is the factored version of 4x squared plus 21x plus 20. And if we want to check ourselves, we can FOIL. So if we were to FOIL, the first term would be x times 4x, that would be 4x squared. Then we're going to do the outside terms, that would be plus 5x. The inside terms, 4 times 4x, will be 16x. And then finally, the last terms would be 20. We combine our like terms, 4x squared plus 21x plus 20. You can see we ended up with exactly what we started. So we can check our answer here. This is our answer. If we want to check it just to make sure we've done it right, we can FOIL it down here, and we should come up with our original expression. But that is our answer using the AC method. That is the factored version of that expression there. Okay. Let's go on to, let's do a couple more examples. Okay, the next example will be 3x squared plus x minus 14 equals 0. Okay, again, our a is greater than 1, so we know our old diamond problem method's not going to work. So we have to do the AC method. So we're going to figure out what a times c is. Well, a is 3, and c is negative 14. So what is 3 times negative 14? 3 times negative 14 equals negative 42. So now we have to find the factor pairs of negative 42. Okay, that when we add those together is going to equal the coefficient of, or is going to equal b. And what is b? B is going to be 1. Okay, so it's plus x. That means we have a lead coefficient there of 1. Okay, so let's start looking at our factor pairs of negative 42. Of course, we got negative 1 and 42, or we have positive 1 and negative 42. Okay, so both of those, negative 1 and 42, when we multiply those together, they both equal negative 42. How about when we add them together? Well, negative 1 plus 42, that's 41, and 1 plus negative 42 is negative 41. We're looking for 1, so we're not there yet. Does 2 go into 42? It sure does. So we'll have 2 and negative 21, or negative 2 and 21. Either one of these, when we add it together, equal 1? No. Because 2 plus negative 21 is negative 19. Negative 2 plus 21 is a positive 19. How about 3? Does 3 go into it? Yes, it does. Remember when we test for if it's divisible by 3, we add the digits together. 4 plus 2 is 6. 6 is divisible by 3. So negative 42 will be divisible by 3. How many times does 3 go into 14? Or 3 go into 42? It goes 14 times. So negative 3 and 14, or positive 3 and negative 14. Neither one of those, when added together, will give us 14. Does 4 go into 42? No, it does not. Does 5? It does not. 5 only goes into numbers that end in a 0 or 5. How about 6? Does 6 go into 42? It does. 6 goes into 42 7 times, so we'll have 6 times negative 7 equals negative 42, or negative 6 and positive 7 equals negative 42. If we add 6 and negative 7 together, that's negative 1. We're still not there. But negative 6 and a positive 7, there's what we want. Negative 6 plus 7 equals a positive 1, so those are our two numbers right there. Okay. So I'm going to erase our factoring work here. We're going to rewrite this equation now, changing the middle term to include these two numbers. So our lead term stays the same, 3x squared. But this middle term, this plus 1, we are now going to say minus 6x plus 7x. Our last term stays the same. Okay, so we didn't really change anything. Okay, we still have negative 6 plus 7x. We combine those like terms, that gives us a positive 1x. So So we haven't really changed anything, but we have changed it to where we can group these first two and these last two and find the greatest common factor in there. So what is our greatest common factor of this term? These first two, 3 and 6, the greatest common factor of that would be 3x. We divide 3x into x squared, what do we get? X minus 2. Okay, if we were to distribute that 3x back through, you would see 3x squared and then minus 6x. So we did that correctly. Let's look at our second term here. We have 7x and negative 14. Looks like 7 will be our greatest common factor. When we take 7 out of 7x, we're left with just x. When we take 7 out of negative 14, we're left with negative 2. And if we've done it right, remember these two parentheses will match up. And they do match up here, x minus 2. Okay. So that'll be our second set of parentheses of our factored form. Our first set of parentheses are going to be these first two, the two terms outside the parentheses here, which would be 3x plus 7. Okay. So there is our answer right here. And if we want to check ourselves by foiling, we multiply the first terms, 3x times x, that gives us 3x squared. Our last terms, 3x times negative 2, negative 6x. Our inside term, positive 7 times x, positive 7x. And finally, 7 times a negative 2, we negative 14. Combining like terms, 3x squared plus x minus 14, and you can see we end up right back where we started. So this is our correct answer right there. Okay, I'm going to give one last example, a third example, and then I will leave you to go do the homework. Our final one will be 5x squared plus 11x minus 12 equals 0. Okay, so we look at this answer and we see a is greater than 1, so we can't use our diamond problem method. We're instead going to use the AC method. So we define AC is 5 times negative 12, so A times C equals negative 60. We have to find the factor pairs of negative 60 that when added together give us a positive 11. So let's start breaking it down. We're going to have negative 1 times 60, that would equal 60. When added together gives us 59, so that's not it. Or you'd have 1 times a negative 60, and that would give you a negative 59. So we keep going. Does 2 go into 60? Yes, it does. 30 times. So we would have, since our number is negative, we'll have 2 times negative 30 or negative 2 times 30. Neither one of those will add together to 11. How about 3? Does 3 go into 60? It does. 20 times. So we will have factor pairs of 3 and negative 20, negative 3 and 20. When those are added together, we still haven't hit still haven't hit positive 11. Does 4 go into it? 4 goes into it, looks like 15 times. So we would have a positive 4 and a negative 15, or a negative 4 and a positive 15. We add 4 and negative 15 together, we get negative 11, close. Negative 4 plus 15, that's positive 11. So there are our two numbers right there. So let's jot that off to the side here. And we'll erase our factor work. I'm going to move on to step 2, which is going to rewrite the equation, changing this middle term using those numbers right there. So 5x squared minus 4x plus 15x minus 12 equals 0. Okay, so let's group these first two and second two. So what is our common factor in 5x squared minus 4x? There's no common factor between 5 and 4. We do have a common factor of x with x squared and x, so we'll pull that x out. We pull that x out of 5x squared, we're left with 5x. We pull that x out of that negative 4x, we're left with a negative 4. How about over here? What would be our greatest common factor between 15x and negative 12? Looks like it's going to be 3. So pull a 3 out of there, and I'll be left with 5x. When I divide 15 by 3, I get 5. X carries down, and negative 12 divided by 3 is going to give us negative 4. And again, are these two parentheses have to match, and we've done it correctly, and they do. So we'll write it in our factored form. Our last set of parentheses will be what is inside the parentheses here, and our first set of parentheses will be the two terms outside the parentheses here, x plus 3. So this would be our answer. If we want to check ourselves, we could FOIL, multiplying the first terms together, x times 5x, we would get 5x squared. Our outer terms would be x times -4 or -4x. Our inside terms would be 15x. And finally, outside terms would be -12. Combining our like terms, 5x squared plus 11x minus 12. And yep, we ended up right back where we started. So this is indeed our correct answer. So hopefully those few examples help explain the steps here pretty well, so you'll be able to get through your homework. If you have any questions, please email.